All right, so now we're going to look at one more quality of the factored form of polynomial functions and how it affects the graph. It's called the multiplicity of a factor. Basically, it's the exponent that is on the factor. So here you can see we have x to the fifth power, so that means that the multiplicity of x, of the factor x, the multiplicity is 5. This factor x plus 2 has an exponent of 12, and that means that the multiplicity of x plus 2 is 12. And then this factor, 4 minus x, has an exponent of 3, and therefore the multiplicity of 4 minus x is 3. Okay? And the multiplicity, note here that this multiplicity is odd. This multiplicity is an even number. And this multiplicity over here is an odd number. Okay? And whether the multiplicity is odd or even or 1, so there's 3 possibilities. The multiplicity can be 1, and I know a 1 is an odd number, but it just looks different when it's a 1. I'll show you what I mean. So what we can see here, do you see how the graph here just simply straight up crosses the line in a basically a straight line? It's curved, but it looks like a straight line. That's when you have a multiplicity of 1. If the multiplicity is 1, the graph will just cross right over at the root, okay? But if the multiplicity is even, then what'll happen is the graph will approach the root, and then it'll touch it, and then it'll go back. It won't cross over at all. Okay, so when the multiplicity is even, there's no crossing over. Okay, it just sort of touches and it turns back the other direction. And then when the multiplicity is odd but not 1, it does this funky thing here. It sort of curves. It curves into the root. It curves into the root. It does this weird shape, and then it sort of flattens out, and then it comes out of the flattening and it goes back up. And so this is an example of what you'll see when the multiplicity is odd, but not 1. Okay. And then this is just another example of even multiplicity, but look, it's on the bottom. It's underneath the x-axis. This one over here is above the x-axis. This one is below the x-axis, but it's the same idea. Okay, if we have x minus 7 squared, that's an even multiplicity, and so what will happen is it'll approach the point and then it'll turn away. Okay, and that is even multiplicity. So let's see some examples of what graphs would look like based on their multiplicity and their roots. And so here we have one. This is really complicated, but you can see it has a degree of 17. We have 5 factors, but technically each one, this one is represented 3 times. It has multiplicity of 3. This one has a multiplicity of 2. This one has a multiplicity of 7. This one has a multiplicity of 4, and then this one has a multiplicity of 1. Now, I've listed that down here. Negative 7 has a multiplicity of 1. Negative 5 has an even. Negative 2 is odd. 1, the root of 1, has an even multiplicity, and the root of 4 has an odd multiplicity. Okay, because it has a lead coefficient of 1, positive 1, and it has a degree that's odd of 17, the end behavior is down on the left and up on the right. And so basically this graph is going to look something like this. It's going to be pointing down on the left, and it's going to be pointing up on the right. Okay, down on the left and up on the right. Okay, we're going to go ahead and mark the roots. We got negative 7, which is right here. We have negative 5, which is right here. We have negative 2, which is right here. We have 1, which is right here. And then we have 4, which is right here. Okay. And so we know that this part of the graph is going to connect to the negative 7, and this part of the graph is going to connect to the 4 over here. Okay, but we just need to figure out what's going on in between. Okay. Well, because -7 has a multiplicity of 1, this graph is just going to straight up, it's just going to cross right over. It's just going to cross right over with nothing interesting, really. But at -5, we have an even multiplicity. So what's going to happen is this is going to have to curve back, and then it's going to go here, and it's going to touch and turn away, because that's what happens when you have an even multiplicity. That looks pretty ugly. Let's try that again. Hang on. Let's try this again. Okay, there we go. And now -5 is an even multiplicity, so it's going to curve down, and then it's going to turn away. Okay. Then it's going to turn back around and go to the -2. It has to turn back around, but this one has an odd multiplicity that's not 1. So it's going to do this flattening out thing and then turn down. Then it's going to turn around and come back to 1. 1 has an even multiplicity, so it's going to touch and turn away. And then it's going to turn back to 4, and 4 has an odd multiplicity, so it's going to flatten out, and then turn up, and then it's going to connect, and it's going to go up. And I know that this is a really crazy looking function or a graph, but this is essentially what you would see from this function. It's going to cross over here, it's going to turn around here because it's even, it's going to flatten out here and then cross over. It's going to turn around here, and here it's going to flatten out and cross over because of the odd multiplicity. All right, let's try some examples that are a little bit easier. Okay, this one is a little simpler. There are only 2 roots. You can see that this one is going to have a root of -4, and this one is going to have a root of 3. So let's go ahead and mark those. Got -4 and 3. Okay. We can see that it's got a negative lead coefficient, so the lead coefficient looks like it's -1. And here's a power of 1, and this is a power of 3, so 3 plus 1 is 4. So this has a degree of 4. Degree of 4, okay? And therefore, the end behavior is going to be down, down, because it has an even degree and a negative lead coefficient, okay? So it's going to be kind of pointing down on the left, and it's going to be kind of pointing down on the right. Okay, now let's see what's going to happen in between. Well, we can see that at -4, the multiplicity is 3, and therefore that's odd and it's not 1. And so what's going to happen is it's going to flatten out here, flatten out, and then cross over. See that? Oops, that's pretty ugly. Try that again. There we go. And then it's going to turn towards 3. 3 has a multiplicity of 1, and therefore it's just going to cross over at 3. And this is approximately what the graph of f of x is going to look like. Let's look at 2 more maybe. Okay, this one looks like we have a lead coefficient of 1. There's no negatives here. Okay, and this has a power of 1, or a multiplicity of 1. This one has a multiplicity of 2. A multiplicity basically means how many x's there are. And so this is 1x here, and this is 2x's here for a total of 3x's. That's x. So this is an x to the 3rd power polynomial, and therefore the degree of this is going to be 3. All right. And so this one is going to have end behavior that looks like this. It's going to be pointing down on the left, and it's going to be pointing up on the right. Okay. Our zeros here are -4 with a multiplicity of 1, and our 0 here, or our root, is -1 with a multiplicity of 2. So that's an even multiplicity. So let's go ahead and plot -1 and -4. We know that on the left it's going to be pointing down, and on the right, I'm going to put it over here because it's closer to the -1, it's going to be pointing up. Since -4 has a multiplicity of 1, it's going to cross right over. And since x plus 1 has an even multiplicity, the graph is going to touch and turn back. And then it's going to connect here. And this is approximately what the graph of f of x is going to look like. Okay. Now let's do one more example. Okay, this one has a It has three factors, x plus 5, x plus 2, and x minus 3. And we can see that x plus 5 has a multiplicity of 1. X plus 2 also has a multiplicity of 1. And x minus 3 has a multiplicity of 2. So if we add 1 plus 1 plus 2, that equals 4. Therefore, this has a degree of 4. It also has a lead coefficient of 1 because we have positive 1, positive 1, positive 1, and in front is a positive 1. Okay, so we have a lead coefficient of positive 1. Therefore, the end behavior is going to be up on the left and up on the right. Our roots are going to be negative 5 here, negative 2 here, and positive 3 here. Okay, and so let's plot those. We've got negative 2 is right here, negative 5 is right here, and positive 3 is right here. Okay, and so we know that we're going to be up on the left, and we're also going to be up on the right. Okay, now if we take this graph and go towards negative 5, we can see that the multiplicity is 1. Therefore, it's just going to cross right over at negative 5. It's going to cross right over. Then when we turn back to go to negative 2, the multiplicity of negative 2 is also 1, so we're going to cross right over. Then when we turn back to go to 3, we see that the multiplicity is even, and therefore we're going to touch, but then turn back, and then connect with this arrow. And this graph is what this function looks like. And that's our last example. But I do recommend you can always use Desmos to better understand. You can use Desmos to better understand these graphs. If you were to type all of these functions into Desmos, they could show you approximately what these graphs look like.